Alright, this is the second part of our video using molar mass. The last video we talked about how to calculate the molar mass. Now we're going a step further and we're going to use the molar mass to convert from moles to grams and back from grams to moles. And there is another step that I will do in the next video, which goes from grams to moles to number of molecules, and from molecules to moles to number of grams. But for this video we will just do this two-step problem, going from grams to moles and moles to grams. So going forward and going in the reverse. So here we have this problem that asks for 12 grams of C6H6 is equal to how many moles. So the first thing we need to do is calculate our molar mass. So let's begin to do that. We have 6 atoms of carbon, and like I said in the previous video, you use your atomic mass from the periodic table. So we're going to round that and say that's 12 grams, plus we have 6 atoms of hydrogen, and the atomic mass of hydrogen is 1 gram. So that is equal to 72 plus 6 grams, and that is equal to 78 grams. So now we can write 1 mole of C6H6 is equal to 78 grams of C6H6. So as I stated in the last video, that was our first step. Now we've calculated the molar mass. Now let's go from grams to moles. Recall that I said that anytime we have this equivalency involving an equal sign, this equation, we can use it as a conversion factor. This is done the exact same way in your textbook. So we start with 12 grams of C6H6, and we want to convert that to moles of C6H6. So 1 mole of C6H6 is equal to 78 grams of C6H6. And when you do that multiplication, or you could call it division, multiplying by 1 over something is the same thing as dividing by that something in the denominator. We would get 0.15 moles of C6H6. So we just did a direct conversion from grams to moles using the molar mass. That is what we just done. So we've already practiced these problems and worked some in class. So I put this together as a refresher. Now we're going to try another problem going from grams again to moles. However, this problem involves one more step, which we shouldn't have a problem with. Okay, so let's now, suppose we had 20.5 20.5 Let's say we had 20.5 micrograms. Let's say we had that mass in grams of C6H6. So now I've gone to using a metric prefix, and that involves one more step in getting to moles. So we would have to go from what, as you recall in chapter 1, micrograms to grams, and from grams to moles. Do not let these prefixes confuse you. We've already done a significant amount of converting in chapter 1, and that was the reason for converting, because you will do this throughout 141 and 142. Okay, so you have to be very familiar with your metric prefixes. So let's tackle this problem. So we have 20.5 micrograms of C6H6. So we need to get out of micro and into grams. So we put the conversion factor of 1 microgram is equal to 10 to the minus what? 6 grams. So now we're out of the unit of micrograms. So when we multiply 20.5 times 10 to the minus 6, we have a unit in grams of C6H6. Now we want to go from grams to moles using the molar mass. And we just found out that the molar mass, 1 mole of C6H6 was equal to 78 grams of C6H6. Okay? So, what do we want? We want moles. Moles goes in the numerator. 1 mole of C6H6. And grams goes in the denominator. Grams of C6H6. Now look what cancels. We have grams of C6H6 in the numerator, grams of C6H6 in the denominator. So these are going to cancel. What unit are we left with? We're left with moles of C6H6. So when we do that multiplication and division, we wind up with 2.63 times 10 to the minus 7. And what unit do we have? We have moles C6H6. Now for some students that have a problem with their calculator, and some of these sophisticated calculators can be confusing, and how it does the order operations is somewhat tricky if you don't enter the numbers correctly. So what I have advised some students, and Mr. Jones has as well, from the 1 to 4 o'clock sessions on Monday and Wednesday, multiply your numerators straight out and get a number. So we have 20.5, we use these parentheses to represent multiplication, times 10 to the minus 6 divided by what we have, 78 times 1, which is 78. So do this operation and get just say X number. Okay. Do that operation and get a number. And then if we had some operation down here other than 78, just say we had to multiply 78 times something, do that operation and get Y number. And then simply divide X by Y and get your answer. Okay? And it is often convenient that when you're doing these multiplications raised to some power of 10 is to put everything in parentheses. So you want to group these things in the numerator together, and you want to group these things in the denominator together to make sure you get the right answer. As well, you want to show all your work on your quiz or your exam, so I can see you're going through these motions of canceling and getting the desired unit and canceling again and arriving at the desired unit. So if you make some type of arithmetic error, I can give you a significant amount of credit without penalizing you heavily, because I can see your setup is right and you know how to put together the correct format in order to solve the problem. Okay, so now let's try another problem. Try something a little bit more in detail, and I'm going to delete that because we're no longer using it. And I'm going to write out the problem. So let's say we want to go from what would be a good one? Let's say we want to go from moles to grams. Let's say we want to go from moles to grams. We just finished going from grams to moles, so let's go from moles to grams. So let's say we have Fe 3 PO 4 parentheses, close parentheses 2. Now, as I reminded you in the last video, this is a part of the same chapter when we did naming compounds, and this is called what? Take a second to think. This is iron. Is this iron 3? No, this is iron 2. This is iron 2 phosphate. You can see when you break that ionic compound up, you get Fe2 plus PO4 with a 3 minus charge. Okay, so I'm off the subject a little bit there, but just wanted to remind you of that. Now, let's say we have 3 moles of iron 3, iron 2, phosphate, and we want to know how many grams of iron 2 phosphate we have. Well, here we are again, back with our friend, using the molar mass. We need the molar mass of iron 2 phosphate to convert from moles to grams. So what did we do in the last video? We said we have 3 iron atoms plus we have a parentheses, we have 1 phosphorus atom times 2, so that would give us 2 phosphorus atoms, and we have inside parentheses 4 oxygen atoms and a 2 outside, so 4 times 2, that would give us what, 8 oxygen atoms. So let's go and plug in these atomic masses. So for iron, come over here to the periodic table. That's iron and phosphate. And what do we have here? Oxygen. So these are the 3 atoms that make up this ionic compound. And let me say, this is not exactly how the periodic table looks. This is just me cutting and pasting particular elements so I can show you where we get our masses from. Okay, so let me say iron, we're gonna round that to 56 grams, plus 2 phosphorus atoms, and phosphorus is, let's say, 31 grams, plus 8 oxygen atoms. We're going to round it to 16 grams. So the total you should get out of that is 358 grams if I calculated it correctly. So 1 mole of Fe3PO42 iron phosphate is equal to 358 grams of iron 2 phosphate. Now, here comes the part that we wanted to solve for. So we have 3 moles of Fe3PO42, and we want to convert that to grams. So in 1 mole of Fe3PO42 is equal to 358 grams of Fe3PO42. Okay, so that is equal to what? Before we say what is equal to, what happens to our units? Moles of iron 2 phosphate cancel. So we're left with 3 times 358 grams of iron 2 phosphate, and that gives us 1074 grams of iron 2 phosphate. Okay, so we just did we just completed a mole to gram calculation using a molar mass. Okay. Now, let's see if we can do one more problem. Now, my advice to you is to pause these videos and see if you get the same answer that I did. You want to go through the same steps that's shown in the text. And see if you can arrive at the same answer. Clean whiteboard. Nice fresh whiteboard. Okay. Now, let's go from let's do another gram to mole calculation. Let's do another gram to mole calculation. So let's see. Let's use a rather large number. Let's go with 1,245 grams of AL2 CO3. And you recognize this ionic compound as being what? Aluminum. Is it aluminum 3? No, it's not aluminum 3 because this is an invariant metal, has only one oxidation state. So this is simply aluminum carbonate. Okay, so to get this ionic compound, we have Al3 plus Cl3 with a 2 minus charge. Just a quick review. Now, (1,245 grams of aluminum carbonate equals how many moles of aluminum carbonate? So the first thing we want to do is what? We need the molar mass. Molar mass again. We need the molar mass of what? The molar mass of this guy right here. So let's start out by saying we have what? 2. Let me write this down. We have 2 aluminum atoms plus, here we go again, inside parentheses we have 1 carbon atom. Outside we have a multiple of 3, so that would be 3 carbon atoms. And here we go again, inside parentheses 3 oxygen atoms. Outside we have a multiple of 3, So 3 times 3 is 9, a total of 9 oxygen atoms. So let's put in some atomic masses. Aluminum on the periodic table right here. And what do we have? Carbon right here again, and oxygen. So as I said in the last video, to calculate the molar mass and do these mole to gram and gram to mole calculations, you will need a periodic table. Okay, so 2 aluminum atoms and we're just going to round it to 27 grams, and 3 carbon atoms, we're going to round it to 12 grams, plus 9 oxygen atoms, we're going to round it to 16 grams. So when we multiply all of this out and add it up, I got 234 grams. Okay, so this is the molar mass of Al2O33 aluminum carbonate. So as I said, I want you to write 1 mole of Al2CO33 is equal to 234 grams of Al2CO33. Okay, so now we can begin to solve solve this problem. And that is a 1 right there, so 1245. Okay, so 1245 grams Al2CO33 times, we want to eliminate grams and keep moles. So 1 mole Al2CO33 is equal to 234 grams of Al2CO33. Okay, so grams of aluminum carbonate cancel, and I'm left with the units of moles of aluminum carbonate. Okay, so when you do this multiplication, you should wind up with 5.321 moles of Al2CO3. And that is your final answer. Okay? So we did a couple of two-step problems. Moles to grams, grams to moles. I did one three-step problem going from micrograms to grams to moles. So in the next video I intend to go from moles to grams, and we can go from grams to another metric prefix of grams, such as micrograms. And also in the next video I plan on going from grams to moles to number of atoms, and from number of atoms to moles to grams. And I also can go from just say, write that on the bottom, I can go from milligrams to grams to moles to number of molecules. I can do that conversion. So that is 1, 2, 3, 4 steps. Okay? We did this in class several times, and this video covered these first 3 steps. Okay, so in the next video I will tack on number of molecules, so we can get from a mass the number of molecules, or we can go from the number of molecules and get the mass. Okay? So practice these two-step problems, and in the case where I threw a prefix in, practice those three-step problems. So if a case showed up like that, I use milligrams for example here, but I did micrograms in the example. So practice these cases where you can get from grams to moles and a prefix to a number of moles. Practice those and make sure that you're firm and solid with doing that before we go to the next step of calculating the number of molecules. As I said before, you should practice a significant number of these problems. The problems I work in class, you should practice those over and over and over again. Take you a piece of nice clean paper and write out the problem. See if you can work it on your own. Go through it without looking at your notes. If you can't, refer back to your notes. Work it out completely. Allow some spacing, 10-15 minutes. Try again. See, can you go through the problem without looking at your notes and get fluent in working these problems. So work the problem 10, 15, 20 times till you get a grip on what you're doing. Again, my scratch paper theory that I got from Dr. Lee, you should have a ton of scratch paper where you've practiced these problems over and over and over again. You will not be able to get the concept just by looking at the notes, just by reading the textbook. You have to practice the problems. So, if there are any questions about what I've done in this video, feel free to ask questions in class, in the tutoring sessions on Monday and Wednesday from 1 to 4, or see one of your tutoring mentors, one of your upper class mentors that we have assigned that can help you work through and understand these problems.